Hi students, we have seen how to solve question number first, second, third, fourth and fifth from exercise 11.1. Now we will solve question number 6 from exercise 11.1. So let's see sixth question. So we will read it carefully. So look here, a bird flies 1 kilometer in 1 minute. Can you express the distance covered by the birds in terms of its flying time in minutes? Here we have to use T for flying time in minutes. So let's see solution of this word problem. So in this example here we have to use T for flying time in minutes. So we consider here T minutes be the flying time which is given in this word problem. Now here distance covered in 1 minute. So if you read that word problem, then you came to know that here a bird flies 1 kilometer in 1 minute. So distance covered in 1 minute is equal to 1 kilometer. But here we have to express the distance covered by the birds in terms of its flying time in minutes. So distance covered in T minutes is equal to distance covered in 1 minute multiplied by flying time. Here distance covered in 1 minute is 1 kilometer and flying time it's given T minutes. So here we multiply 1 by T, we get T kilometer. So what is our rule? Distance covered in T minutes is equal to T kilometer. Okay, so let's see next question. Radha is drawing a dot rangoli, a beautiful patterns of lines joining dots with chalk powder. She has 9 dots in a row. How many dots will her rangoli have for R rows? How many dots are there if there are 8 rows or if there are 10 rows? So now you read that word problem carefully, then you came to know that here by chalk powder Radha is drawing a dot rangoli with a beautiful pattern of lines joining dots. Here she has draw a 9 dots in a row. So look here, let's see solution of this word problem. Here number of dots in a row is 9 and here we have to find the rule for R rows. So number of rows are R. Now we have to find here how many dots will her rangoli have for R rows. So here total number of dots in R rows is equal to number of dots in a row multiplied by number of rows. Here number of dots in a row is 9. So 9 and number of rows are R. So we multiply 9 by R. So here we get rows. Total number of dots in R rows is equal to 9R. Also we have to find out how many dots are there if there are 8 rows. So here number of dots in 8 rows. Here we put the value of R is 9. So 8 multiplied by 9, 8 9s are 72. So number of dots in 8 rows are 72. Also we have to find out if there are 10 rows. So here number of dots in 10 rows. So here number of dots in a row are 9 and number of rows are 10. So 10 multiplied by 9, 10 9s are 90. So see student, here number of dots in 8 rows are 72 and number of dots in 10 rows are 90. Now let's see next word problem. 8. Leela is Radha's younger sister. Leela is 4 years younger than Radha. Can you write Leela's age in terms of Radha's age? Take Radha's age to be X years. So let's see solution of this word problem. Here Radha's age be X year. We have to take it. So here we take Radha's age is X year. Now Leela's age is 4 years younger than Radha. So we have to subtract 4 from Radha's age. Radha's age here X years. So here Leela's age will be X minus 4 years. Next, ninth word problem is mother has made laddus. She gives some laddus to guests and family members. Then also still 5 laddus remain. If the number of laddus mother gave away is L, how many laddus did she make? So let's see solution of this word problem. Here number of laddus mother gave is L and she distribute those laddus to the guests and family members. Then also 5 laddus remain. So remaining laddus are 5. So how many laddus? Total number of laddus here we have to find. So total of number of laddus. So number of laddus given away by mother plus number of remaining laddus. So we have to add to get the total number of laddus. Here number of laddus mother gave to guest and family are L and remaining laddus are 5. So we add, we get L plus 5 laddus. So answer of total number of laddus is L plus 5 laddus. Now next question, question number 10. Oranges are to be transferred from larger boxes into smaller boxes. When a large box is emptied, the oranges from it fill 2 smaller boxes and still 10 oranges remain outside. If the number of orange in a small box are taken to be X, what is the number of oranges in the larger box? So let's see solution of this example. Now here number of oranges in small box here taken to be X. So here we write X. Now here in a small box is X. So 2 small boxes, so we multiply by 2. So number of oranges in 2 small boxes are 2 multiplied by X, 2X. Then also remaining oranges are 10. So number of oranges remain is equal to 10. But here we have to find out number of oranges in a large box. So how to find it? So number of oranges in 2 small boxes plus number of oranges remain. Here number of oranges in 2 small boxes are 2x and remaining oranges are 10. So we add it, we get 2x plus 10. So number of oranges in large box is equal to 2x plus 10. Now let's see next word problem 11. Look at the following mastic pattern of squares which is given in figure 11.6. Here the squares are not separate. 2 neighboring squares have a common mastics. Observe the patterns and find the rule that gives the number of mastics in terms of number of squares. Here hint is given, if you remove vertical stick at the end you will get the pattern of C. So look here this figure. Here last square and if we remove this mastics, so we get letter C. So let's see solution of this example. Here observe, if we observe this given mastic pattern, here For 1 square we need 1, 2, 3, 4. 4 mastic. If 2 squares are there, then how many mastics required for us? 1, 2, 3, 4, 5, 6, 7. For 1 square 4 mastics required. For 2 square 7 mastics required. If we want to form 3 square, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 means in this pattern, if you observe here, we may observe that in the given mastic pattern, the number of mastics are 4, 7, 10 and 13. Means in this pattern, one more than the thrice of the number of squares in the pattern. Means here 3x plus 1, where x is the number of square. See student, here which pattern we got? 3x plus 1. What is meaning of that? 1 more than the thrice the number of square, where x means number of square. So we get here rule of this pattern. Now see next. Here next figure is 11.7. Here also gives a mastic pattern for triangle. As in exercise 11a, above find the general rule that gives the number of mastics in terms of number of triangle. So see its solution. Here if you observe this mastic pattern, here for one triangle, how many mastics needed for us? 3. Now second pattern 1, 2, 3, 4, 5. For next pattern, first pattern we need 3 mastic. Second pattern 5. Then next C pattern 7. And for D pattern 9. Means here one more than the twice of the number of triangles in the pattern. Means in first pattern here one triangle make, in second 2, in third 3 and next 4. Okay, so one number of triangle is more. So here how we get pattern for it? So look here one more than the twice of the number of triangle. Twice of the number of triangle. Means here we get pattern 2x plus 1. Means suppose if number of triangle is 1, if we put the value of x is 1, so we get here 2 ones are 2 plus 1 3. So here for one triangle 3 mastics required. Now if in this pattern we put the value of x is 2, means suppose we have to make here 2 triangle. So if we put value of x is 2, 2 2s are 4, 4 plus 1 5. So next to make a 2 triangle we need 5 mastics. Suppose if we put here a number of triangle is 3. So 3 multiplied by 2, 3 2s are 6, 6 plus 1 7. Means for 3 triangle we need here 7 mastics. In this way pattern we get 2x plus 1. That is the rule for this pattern. So we have solved here all questions given in exercise 11.1.